let's move on to this idea of functions, and also they're called functions and relations. They work together often. So this is sort of the beginning of, this is really going to be some algebra that we're doing here. Less pre-algebra, we're going to talk about functions, relations. We're going to start talking about um, how they relate to each other and how they relate to like a line when a graph. So a lot of times you'll see and hear these called linear functions. All right, well first let's define what a function is. So a function is a pairing of each number in a given set with exactly one number in another set. So this is kind of like that activity that we did in class. You used your vertical line test. I also showed you a little bit about how to do it with mapping. That's really what it is. It's one pair, right, of a given set with exactly one number in another set. So two things you're going to need to know. Input, it's the set of all numbers that you put into the function, okay? This is also known, there's another word we use for it that you're going to talk about later when we get into algebra. It's called domain. You don't need to know that right now, but I just want to introduce it to you. This is also called domain. And then you have output. This is the set of all numbers that come out of the function, okay? These are going to be your y coordinates. And then that's also called range, okay? So domain and range. But really just think of x and y, okay? Think of it as this is your independent variable and this is the dependent variable, okay? So what you put in, right, what comes out is going to depend on what you put in, right? So trying to relate all this back to each other. All right, so evaluating function. We did this a little bit already, but I want you to just sort of, this is what happens, okay? This is a function, y equals 5x, okay? So what I want to know is what happens when I put in 7, okay? My input is 7. What's going to happen? I'm going to plug it in, right, and rewrite it. Y equals 5x. I'm going to substitute in 7. I get 5 times 7. Well, what is 5 times 7? Well, 5 times 7 is 35, okay? So y is equal to 35 when x is 7, okay? So the output is 35 when the input is 7, okay? Hopefully that makes sense, because sometimes what's going to happen is I'm going to say, what's the rule if your input is 7 and your output is 35? Well, let's do this. Let's make an input-output table for the following functions, okay? So what we're going to do is, here's my input-output, and this is like a traditional domain, 0, 1, 2, 3, 4. A lot of times you'll see -2, -1, 0, 1, and 2. You know, it's a good idea to pick 0 and then a couple of negatives and a couple of positives, but let's just make this as easy as we can right now. So here is our function, y equals x plus 3. So let's just go ahead, and what we're going to do is we are going to just fill this out, okay? If x is 0, y is 3. If x is if x is 1, y is 4. If x is 2, y is 5, 6, and 7. And you'll notice really what's happening is the output is 3 bigger than the input, right? That's what this says. Whatever you put in, make it 3 bigger, that's what you get out, okay? Plug in 0, get 3, 1, 4. All right, and on and on and on. All right, so that would be the input-output table for our first one. All right, let's go ahead and let's see, gotta get it on the. Okay. Let's try another one. Start working. There we go. X equals y equals x minus 2. So what we're gonna do is whatever goes in, okay, whatever goes in here, is we're gonna take away 2. So 0 minus 2, this is gonna be -2. 1 minus 2 is -1, 2 minus 2 is 0, 3 minus 2 is 1, and 2, okay? So this is x minus 2, right? And then let's go ahead and do another one here. Y equals -2 times x. Okay, so let's try this one. So -2 times 0 is going to be 0. 1 times -2 is -2. This will be -4. This will be -6. This will be -8. Okay, and on and on and on. And last one here. Let's try. Okay, y equals x divided by 2. Now notice I switched out the input. I wanted even numbers, that if I divide by 2, it makes it a nice whole number. Okay, so 0 divided by 2, 0. 2 divided by 2 is 1. 4 divided by 2 is 2. This will be 3 and 4. Okay. So just a little practice of input-output rules. Okay, so let's move on. All right, now make an input-output table for the function y equals 2x plus 2. All right, the domain is -2, -1, 0, 1, and 2. Remember, domain means input. Okay, then state the range. That means output. Domain and range, input, output. All right, so I'm just going to show you the solution here, and you can, if you have any questions, but it's basically just kind of showing you how you do it. Okay, input -2, -1, 0, 1, 2. Now notice they used a a horizontal chart this time. I did a vertical chart. You'll notice I'll explain later in this video why I use the vertical one. Okay, so this is how they get it. If you do have any questions on how to do this, just bring them to class. But just another example. Okay, so the output on this would be, all right, if the input is -2, then the output is -2. -1 input 0, and on and on and on. Okay, well let's move on. Let's start talking about this thing of actual linear equations. Okay, linear means line. Equations are two equal expressions, right? So what we're going to do here is we're going to say, all right, well 2x minus y is equal to 5. What I'm going to do is I'm going to give you an ordered pair, and we're going to see, does that actually work? Okay. So what this is really saying is this here, the solution, what this is actually going to look like, this is going to look like a line, okay? And a line is just a whole set of points that are all together that form this, that when you connect them, they make a straight line. Kind of think about like ants on a sidewalk, right? If you look at it far away, it looks like a line, but when you get closer, it's a bunch of different ants. It's kind of like the dots, okay? All right, so what we're going to do here is we're going to say, all right, 1, -3. Does that actually fit in here? So if I plug in 1 and -3, okay, and I evaluate this side, will it be equal to 5? And if it's true, that means that this point is on this line. And all of this will make way more sense as we start getting more into this. I just need you to be able to sort of check to see, does my solution work, okay? Just bear with me here. If it doesn't make total sense right away, it will later, I promise you. All right, well, let's go ahead. And what I'm going to do here is I'm going to just plug it in, okay? And that's my work here. So I said, okay, 2 times x minus y is equal to 5. I'm going to substitute. This is x and this is y. So I plug it in. 2 times 1 minus a -3, okay? Well, 2 times 1 is 2. And subtracting a -3 would be the same as adding, so it's going to be +3. So 2 plus 3, that's 5. Does that equal 5? Yes, it does. Okay, that means 1, -3 is a solution. Okay, it works up here. Well, let's take a look at one what doesn't work. Right, 4, 7. Plug it in. 2 times 4 is going to be 8. All right, subtract 7. 8 minus 7 is 1. Is 1 equal to 5? No, it doesn't. So this point right here is not a solution, okay? So what you want you to do is picture a line, okay, through a coordinate plane. Basically what it's saying is 1, -3. If you plot that point, this line goes through here, okay? But it doesn't go through this point, okay? This is not on the line, okay? So it's sort of like if I let's see, 1, -3. So if I draw a line, draw a line across here, 1, -3 might be here, okay? But 4, 7 is not going to be on the line. That's really all this is saying. Okay, so 4, 7 is not a solution. All right, now, when we actually graph these, okay, first, we're going to make an input-output table, okay? And now you already know how to make an input-output table. So why don't you go ahead and pause the video and make your input-output table for this right now. Go. Okay, well, hopefully when you did that, you got -5, -3, -1, 1, and 3. All right, if you have any questions on how this works, bring them to class, okay, if you didn't get this. Okay, now, what's going to happen here is, notice, these are x's and these are y's. When I have when x is -2, -5 is what comes out. This is what I plug in, this is what comes out. This is my independent variable, this is the dependent variable on this, okay? So I can turn those into points, and that's what this is saying. I basically just took this and turned them into points, and this is why I like the vertical style. They look like points. Once you look at this, it's much easier to see points. In my opinion, you can use the horizontal style if you'd like. It really doesn't matter to me, as long as you are able to generate your points using an input-output table. Okay, now what we're going to do is we're going to take these points, okay, and we're going to plot them on this graph here, okay? And as you plot them on this graph, it's going to make a line. And that's the whole point. Pun intended. All right, so let's move on. Now you try. And what I want you to do is I want you to generate an input output table, and then I want you to go ahead and I want you to plot these points on that graph. Go. Okay? Hopefully when you did this, you put in, you got 7, 4, 1, -2, -5. If you didn't get these, bring them to class, okay? It's probably because this is, you have to kind of think of this as being a plus a -3. So it's -3 times -2, which would be +6. So 1 plus 6 is 7. Okay, that would be my guess is why you didn't get it right the first time. Okay, and you notice, again, boom, line. Perfect. Okay, perfectly straight. If you one of these things is maybe it looks maybe a little bit off, but it's just because the software, I couldn't get this point to be perfect on there. So if one of these points is way off, then you probably made a mistake somewhere. And this is why we like to do 5 in a row, because if you do 5 and one of them is off, it's easy to see. If you only do 3 and one of them is off, you don't know which one it is, which one is the mistake. Okay, this one is, if only one of them is off, you probably can figure it out. All right, so let's go ahead and let's look at this. Let's look at another one when y is equal to 2. If y is equal to 2, notice this doesn't have any x coordinates. And really what this is saying is, where is the line y? Where is y equal to 2? Well, guess what? Y is equal to 2 there. Everywhere along this line, okay? It doesn't matter what x is. X could be anything. Y is 2, okay? And then if I have something that looks like x equals -3, okay? Well, x is -3. Well, where is that? Okay, that is that line right there. This is where x is -3, okay? If you think about it, that's what these grid lines are basically saying. When you plot a point like -3, 2, what you're saying is where the line of x is -3, right? You even go up this line. You say, okay, where's x -3? It's here, and you move over to 2 here. Okay, so that point is -3, 2. But that's what these lines are. Okay. All right, that's it. Bring your notes to class. I'll check them tomorrow, and we will move on and start graphing like crazy. All right.